Uh, in dynamic vote assignment protocol, uh, the number of votes which are assigned to a particular site used to change dynamically. For that, I can illustrate an example that how the dynamically vote reassignment is being done to the different sites which are participating uh, by considering that that the read quorum and the write quorum, that is R is equal to 3 and W is equal to 3 for this particular system which is shown. So if anyhow uh, a network partition is going to separate the site 4 from the rest of the system, then in that case site 1, site 2 and site 3 can still collect the quorum, that is the majority, while site 4 alone cannot find this, it is not able to collect the quorum because it is being partitioned. And now if another partition has been made for the site 3 from its group, 1, 2, 3 was in a group, now another partition has been made, then in that case we have 3 partitions now. In one partition it will be 1, 2, another partition will have 3, another partition will have 4. So in that particular case, no partition will be able to collect the quorum, and the system cannot execute any kind of read request or the write request. Now, the above situation can also occur if the site 3 and site 4 is going to fail. So we must need a situation in which the sites are going to be failed, or if there is a partition. Anyhow, the votes which are assigned to the different sites, it should be reassigned so that every site will be able to collect the quorum. So we are able to reduce the likelihood of the above situation by increasing the number of the votes which are assigned to the group 1, 2, 3 before the second partition or the failure is going to happen or occur. So, and it is done in such a manner that after any failure, the majority group, that is 1, 2, 3, dynamically it is going to reassign the votes in order to increase the voting power and increase the system chances of surviving the subsequent failures. Now, in this particular instance, the voting power of 1, 2, and 3 is 1, 1, 1. And if it is increased to 5, 5, 5, so the total number of the votes will become 5 plus 5 plus 5 plus 2, 17. Now, if the second failure occurs, even though, means 4 has been failure, 3 has been failure, even though the total number of the votes are 17, even though the partition 1 and 2 will be able to collect 10 votes because the vote reassignment is 5 and 5. So the total votes will be available for 1 and 2 will be 10, which is more than for the quorum. So the quorum can be collected even though the sites are going to fail or there is a partition by reassigning the votes. Now this idea of dynamic vote reassignment was given by Gifford, and and we have categorized 2 ways by which the reassignment of the votes can be done. The one is the group consensus and another is the autonomous reassignment. Now, in case of group consensus, uh, the sites which fall in the active or the majority group, they are agreed upon the new vote assignments, using either a distributed algorithm, or by electing a coordinator to perform the reassignment of the vote. And the sites which are outside the majority group will not be able to receive any votes. Means the sites which are outside this majority group will not receive any vote. Now, this method relies on the active group participation. So the current system topology must be known before we are going to decide the vote assignments. And by using this information, that is the current system topology, this method can make an intelligent vote assignment that will be more resilient to the future, for the future failures. However, the deciding of the vote assignments and installing it are a little bit complicated, and it cannot be done very easily. However, a good vote assignment requires accurate information about the current topology. So that is the group consensus. Second one is the autonomous vote reassignment. In this, each site uses a view of the system to make a decision about the changing of its vote, and then going to pick a new vote value, without regard of the rest of the sites. So in this method, a site essentially tries to obtain all the votes or the part of the votes of a site that have been separated from the majority group. And before the change is made final, the site must obtain the approval of its vote change from a majority to ensure that there should not be any problem related with the mutual exclusion, because the voting mechanism should not be compromised with that. So since each site operates on its own, so the global vote assignment may not be as effective as compared to the vote assignment in the group consensus method. That is why group consensus method seems to be better method than the autonomous. However, this autonomous vote reassignment method is quicker, it is simpler, it is more flexible, even though the group consensus vote reassignment method is better considered. Now, the transaction and the concurrency control is the next unit which we have to discuss. And before we go into the detail, let us first discuss about the transaction. What is transaction? A transaction, as far as the DBMS is concerned, it is the abstracted view of a user's program, meaning thereby the sequence of the read operation as well as the write operation. So the collection of the operation that forms a single logical unit of the work is known as transaction. Now, as far as the database system is concerned, the database system must ensure the proper execution of the transaction, even though if there is any failure. So this, despite of any failure, either the transaction should execute, entire transaction should execute, or none of it, none of it does execute. Just to elaborate that particular part, the database system must manage the concurrent execution of the transaction in such a way that it should avoid the inconsistency. If you take an example of the fund transfer, in which the transaction which is computing the customer's total balance might see the checking account balance before it is debited by the fund transfer transaction, but it sees the saving balance after it is being credited. So you can call this transaction as a logical unit of the work which is done on the database, and it is the entire program or the portion of the program with a single command. So we can say that a transaction is a unit of a program execution that accesses and possibly updates the various data items. Usually the transaction is initiated by the user program, which is written in the high level programming language with the embedded database accesses. And you can say that the transaction is demarcated by the statements of the form of the begin transaction and the end transaction. And this transaction consists of all the operation which is executed between the begin transaction and the end transaction. So this collection of steps, it must appear to the user as a single unit. And you can call that it should be indivisible in the form of an indivisible unit. So since the transaction is indivisible, it either executes its entirety or not at all. Therefore, if a transaction begins to execute, but it is going to fail by a certain reason, whatever reason may be, any changes which has been made into the database that the transaction have done, it should be undone. Now, this requirement of doing the transaction undone holds regardless of whether the transaction itself has been failed, or the operating system has crashed, or the computer itself stopped operating. So we have to anyhow ensure that this requirement must be met. However, for meeting this requirement, it's difficult because it may be possible that there are some changes in the database and it might still be stored in the main memory variables of the transaction, while other may have written onto the database or stored on the disk. So this kind of all or none property is referred to as atomicity. So what actually the atomic transaction is, because we have certain property of the transaction, that is, it should be atomic, it should be consistent, it should be isolated, it should be durable. So first of all, we must know what is atomic transactions. You can say that an atomic transaction is a computation consisting of collection of operations that take place indivisibly in the presence of the failure, and as well as in case of concurrent computations. Meaning thereby either all the operations are performed successfully or none of their effect prevails. And other processes which are executing concurrently cannot able to modify or observe intermediate states of the computation. So this transaction helps to preserve the consistency of a set of the shared data objects in case of failures, as well as in case of concurrent accesses. Because it will be very necessary, because they have to recover from if there is any crash. So this is going to make crash recovery much easier, because a transaction can only end into the two states. Transaction carried out completely or transaction failed completely. So the transactions, as I told that it has the essential properties, and the first property is the atomicity or the atomic property. Now the atomicity property ensures that to the outside world, all the operations of a transaction appear to have been performed indivisibly. Of course, it will take certain step, but to the outside world, to the user, it should seem that there is a single operation which is being performed. So there are two essential requirements for maintaining this atomicity with respect to the failure, as well as with respect to the concurrent accesses. So the first one is called failure atomicity, and the second one is called concurrency atomicity. So the failure atomicity is going to ensure that if a transaction's work is interrupted just because of the failure, any partially completed results will be undone. And this failure atomicity is also known as all or nothing property, because a transaction is always performed either completely or not at all. On the other hand, if we talk about concurrency atomicity, it is going to ensure that while a transaction is in progress, other processes which is executing concurrently with the transaction cannot modify or observe any kind of intermediate states of the transaction. So, and only the final state should be visible to the other processes after the transaction is completed. Now, this concurrency atomicity is also known as consistency property, because a transaction moves the system from one consistent state to another consistent state. So the second property is the known as isolation. Isolation is also known as serializability. So this property, isolation property, ensures that if there are certain transactions which are concurrently executing, it should not interfere with each other. That is, the concurrent execution of a set of two or more transactions should be serialized. And it should be serialized in the sense that the ultimate result of performing them concurrently is always the same as if they have been executed one at a time. So that is the meaning of isolation or the serializability. The last one is the durability. This property is also known as permanence. This durability property ensures that once a transaction completes successfully, the result of the operations become permanent and it cannot be lost even if the corresponding process or the processor on which it is running, it is going to crash. So that it should be available after it recovers from the crash. So this property in the mnemonics form, it is known as ACID property, where ACID are the first letters of atomic consistency and isolation and durability, where the uh, A stands for atomicity, that is failure atomicity. The second one is consistency, that is consistency atomicity. Third one is isolation, that is serializability. And fourth one is durability, that is the permanence. Therefore, the property of the transaction, this property of the transaction is known as ACID property. Now let us discuss about the transaction states. Now, it is possible that a transaction may not always be able to complete its execution successfully. Such a transaction is said to be aborted. And if we are to ensure the atomicity property, an aborted transaction must have no effect on the state of the database. Meaning thereby any changes that the aborted transaction made to the database must be undone. And once the changes caused by the aborted transaction has been undone, we can say that the transaction has been rolled back. Now, it is the part of the responsibility of the recovery scheme to manage the transaction aborts. And this is done typically by maintaining a log. Each database modification which is being made by a transaction is first recorded in the log. We record the identifier of the transaction performing the modification, the identifier of the data item being modified, and the old value prior to the modification, and the new value after the modification of the data item. All these three are stored in the log. Only then the database itself is going to be modified. So Maintaining a lock provides the possibility of redoing the modification to ensure the atomicity as well as the durability, as well as the possibility of undoing a modification to ensure the atomicity in case of the failure during the transaction execution. So a transaction that completes its execution successfully, it is known as committed, is said to be committed. And a committed transaction that has performed the updates transforms the database into new consistent state, which must persist even if there is a system failure. So once a transaction has committed, we cannot undo its effect by aborting it. It's not possible. The only way by which we can undo the effects of the committed transaction is to execute a compensating transaction. How it can be done? Let us take an example. Suppose a transaction has added rupees 20 in your account and you want to abort it. So you must require a compensating transaction which will subtract 20 rupees from your account. But it is not always possible to create such compensating transaction. That is why once the transaction has been committed, it cannot be undone. So therefore, we are in requirement of to be more precise about what is actually the meaning of the successful completion of a transaction. Therefore, we are going to frame an abstract transaction model which has different states as shown in this particular figure. This state is the active state, partially committed, failed, committed, and aborted. So what is the active state? The active state is the initial state, and the transaction stays in that state while it is executing. What is partial committed? After the final statement has been executed, it will change to the partial committed state. Failed state. Failed after the discovery of the normal execution can no longer proceed. It means it is a failed state. Aborted after the transaction has been rolled back and the database has been restored to the prior state, which was at the start of the transaction. And committed after every successful completion, it is in the committed state. So we can say that a transaction has committed only if it has entered into the committed state. Similarly, we can say that transaction has aborted only if it is entered into a aborted state. A transaction is said to have been terminated if it has either in the committed state or in the aborted state. So any transaction starts from the active state, and when it finishes its final statement, it enters into the partial committed state. And at this point, the transaction has completed its execution, but it is still possible that it may have to be aborted since the actual output may still be temporarily residing in the main memory. And thus, a hardware failure may going to preclude its successful completion. So the database system then writes out enough information to the disk at that particular moment of time. Even in the event of the failure, the updates which are performed by the transaction can be recreated whenever the system restarts after the failure. And when the last of this information is written out, the transaction enters into the committed state. So the transaction enters into the failed state after the system determines that the transaction is no longer able to proceed with its normal execution just because of the hardware failure or the logical error failure. So such a transaction must be rolled back. So then it is going to enter into the abort state. So at this particular point, we have now two options. Whenever it is going to abort its state, it can restart the transaction, but only if the transaction was aborted as a result of just because of the reason that there is a hardware or the software error that was not created enough the internal logic of the transaction. So a restarted transaction is considered to be a new transaction. So the first one is that it can restart the transaction, or second one is it can kill the transaction. And this killing of the transaction usually done because there are some internal logical error which cannot be corrected only by rewriting the application program, or just because the input was bad, or because of the desired data were not found in the database.